Now we studied finding of equivalent weights in disproportionation reaction. So how can you find equivalent weights in disproportionation reaction? We can explain by taking examples. So here I take an example, you see, Br2 in basic medium, it can be formed as Br minus plus BrO3 minus. Okay, it is a reaction. It is a disproportionation reaction. Disproportionation reaction means an element in one oxidation state, it can be undergoes simultaneously, it can be oxidized and reduced. That is called disproportionation reaction. So when you take this reaction, here on Br2 oxidation state is 0, and in Br minus here it is -1, and here it is the oxidation state +5. Okay, so an element with an oxidation state simultaneously it undergoes oxidation and reduction. That means it is simultaneously oxidized and reduced. In that condition it is called disproportionation reaction. Okay, so in this disproportionation reaction, now we want to find equivalent weight of Br2. Okay, for finding equivalent weight we take like this, you see. So we take oxidation and reduction reaction separately. So Br2 to Br minus 0, it converted to -1. That indicates it is reduction. So first I take like the reaction, you see, Br2, it can be formed as Br minus. Okay, so here you see, first we can balance that bromines. Here Br2 means 2 bromines are present, but here Br minus 1 bromine only present. So on balancing, we write Br2 gives 2 Br minus. Okay, now the here bromines can be balanced. Okay, now you can find the oxidation state. 2 bromines are present, 2x, and here there is no charge, so that's why we write 2x is equal to 0. Okay, here also 2 bromines are present, 2x, but charge is present, 2 minus, that means -2 is present. Okay, so here you see 2x is equal to 0, and here 2x is equal to -2. So when you see the difference between these two, 0 to 2 -2 means here total 2 electrons. 2 electrons can be exchanged. Okay, so that's why here n factor value can be taken as 2 for this reaction. It is reduction. Okay, after that next you see Br2 oxidation state 0, BrO3 minus oxidation state 5, it is oxidation. So in this oxidation we can see what is the n factor. Br2 gives BrO3 minus. Okay, so here also see Br2 means 2 bromines are present, in BrO3 1 bromine only present. So first we can balance that bromines. So for that we write Br2 gives 2 BrO3 minus. Okay, right, now we can find oxidation state. Br2 means 2 bromines are present, so we write 2x is equal to 0. Here 2 bromines, so we write 2x, and oxidants you see 2 into 3 means 6 oxygens, and here oxygen it is present in oxide form. So here charge can be taken as -2. 6 oxygens means 6 into -2 is -12, and 2 minus charge is present. So here we write -2. So you see 2x -2, whenever you write this side +12, +12 -2 means it is 10. Okay, right, now we see here 2x is equal to 0, and here 2x is equal to 10. So total here 10 electrons can be exchanged. Okay, so here n factor is 2 and here n factor is 10. We take the 2 n factors by taking that equivalent weight of Br2. So while finding equivalent weight, general formula is molecular weight by n factor. So here molecular weight can be taken as m by, here n factor is 2, plus here molecular weight m by n factor is 10. Okay, so here 2 and 10 is present. When you can take the LCM, here LCM is 10. So 2 5s are 5 into m, 5m, plus here m is present. Total it is 6m by 10. That means nothing but it is 3m by 5. Okay, it is the equivalent weight of bromine. Okay, if you want to find the value, in place of m we take molecular weight of Br2. So you see 3 into bromine, it is present 2 times. So we take 2 and its atomic weight is 80 by 5. We take like this. Okay, you see 5 1 is 5, 5 1 is 5, and 3 is present 30, 5 6 is 30. Okay, so you see total 3 into 2 6, 6 into 9 16, it is 96. So in this reaction, equivalent weight of Br2 can be taken as 96. Okay, once you see, it is a disproportionation reaction. Disproportionation means an element with one oxidation state, it simultaneously oxidized and reduced. In oxidation, oxidation number increases. In reduction, oxidation number decreases. Okay, so we take separately oxidation and reduction. By using this, first we can find n factor values. After finding that n factor, if you want to find equivalent weight, we take molecular weight by n factor. Here n factor is 2 and here n factor is 10. So we write m by 2 plus m by 10. Okay, by taking this, here equivalent weight of Br2 in this reaction is 96. Okay, it is one example to find equivalent weight in disproportionation reaction. Okay, right. Now we take another example. Okay, here we can find equivalent weights for compounds or molecules which involved in disproportionation reaction. Okay, now we can take another example for disproportionation reaction. Okay, you see, it is second example. P4 phosphorus in basic medium, it can be present as it can be formed as PH3 plus H2PO2 minus. Okay, it is also a disproportionation reaction. P4 phosphorus in basic medium, it forms PH3 and H2PO2 minus. Okay, now we see oxidation state. P4 means your oxidation state can be taken as 0. In PH3, hydrogen plus 1, 3 hydrogens are present, that's why here it can be present as -3. And in H2PO2, hydrogens 2 hydrogens, oxygen 2 oxygens means -4, -4 plus 2 means -2, and when here -1 is present, total here phosphorus we get oxidation state +1. Okay, so you see an element with one oxidation state, it can be simultaneously undergoes oxidation and reduction. That's why it is a disproportionation reaction. Okay, in this you want to find equivalent weight of phosphorus, so we take reduction and oxidation separately. So first I take reduction reaction. Okay, it is reduction because here its oxidation state can be decreases. Okay, P4 gives PH3. Right, first you should balance phosphorus. P4 means 4 phosphorus are present, here only 1 phosphorus is present, so right, P4 gives 4 PH3. Okay, now phosphorus should be balanced. Okay, so while writing equivalent weight, first we can balance these 4. P4 means 4 times phosphorus is present, here only 1 phosphorus is present, that's why it is multiplied with the 4. Okay, right, now you see 4 phosphorus means here write 4x is equal to 0. Now here 4 phosphorus, 4x, and 4 into 3, 12. 4 3 is 12, 12 hydrogens are present, plus 12, 0. Now 4x is equal to -12. Okay, you see here 0 is present and here -12 present means n factor can be taken as 12. Okay, so here a total 12 electrons can be transferred. Okay, right. Now we take oxidation reaction. In oxidation, P4 gives H2PO2 minus. It is oxidation reaction. Here also first we can balance phosphorus. 4 phosphorus are present, but here only 1 phosphorus is present. That's why P4 gives 4 H2PO2 minus. Now here 4 phosphorus, here also 4 phosphorus are present. Now we write the oxidation state. Here it is 4x is equal to 0. Now we see 4 into 2, 8, and 4 phosphorus are present, 4x. And you see 4 into 2, 8 oxygens. 8 and oxygen is having -2 charge. So 4 into 2, 8 oxygens. 8 into -2, -16. It is present. So here -16. And 4 minus means this side we write -4. Okay. 8 minus 16 means it is nothing but -8. And here -4 is present. 4x is equal to -8. When you write this side, it is plus side. So it is 4. Okay. So you see here 4 electrons are 0 to 4 means total 4 electrons can be transferred. Okay, so now we want to find equivalent weight of P4. So while writing equivalent weight of P4, we write molecular weight. Here molecular weight can be taken as m. Here n factor in reduction, n factor is 12, and in oxidation n factor is 4. So we write m by 4. Okay, by taking like this, we can find equivalent weight of P4. Okay, so it is finding equivalent weight in disproportionation reaction. So whenever a disproportionation reaction is given, in that one element with one oxidation state, it simultaneously undergoes oxidation and reduction. So if you want to find which is oxidation, in oxidation, oxidation number increases. In reduction, oxidation number decreases. Okay, here you want to find equivalent weight. If you want to find the equivalent weight, you take that oxidation and reduction reaction separately, and from that we can find n factor value. After finding this n factor value, if you want to find equivalent weight, molecular weight by n factor we write separately. By combining we get equivalent weight for the compound. Okay, like that we can find the equivalent weights of compounds in disproportionation reactions.